In the previous video, we ended up creating this nice roadblock photoscan 3D asset. I would happily use the assets like that in a game-like context. I think it passes the quality test. That being said, the base color texture is still on a blurry side if you ask me, especially if it's gonna be used in the VFX context. So we can still try to crank it up to 11 out of 10 and pass the fairly low-resolution base color texture through the algorithms of neural network-based upscaling. You'll need a tool called Upscale. It can be downloaded from GitHub, it's free. It needs a little bit of setup, namely installing all dependencies like Python and having a decent video card that supports CUDA. By the way, if you will have hard time installing dependencies, it can be done via the settings of the app. There's a button in there that says Install Dependencies. Right now, after some zoom in, we can definitely tell that there are blurry parts and the effective resolution is not as high as the actual resolution that is revealed in numbers, meaning that we can probably render it out from that perspective in 40% of the resolution, or maybe slightly higher, in half of the resolution, and it will be the real effective resolution for that asset, taking the far from perfect lens of a mobile camera into account and other things that contributed to the blurriness. So let's try to upscale that low resolution image. I'm creating a separate folder for it and using the uncompressed TIFF format for storing it. It's 960 by 540 resolution. So let's mention it in the file name. Here's the Upscale free application that can be downloaded from GitHub. What we need to do to upscale our low-res image is to drag and drop it into the central portion of the user interface, like that. And then choose the model of Generative Adversarial Neural Network, or GAN. Here we have 3 models, and after some testing, I had most success with the third one called Real ESR GAN. So let's go for it. The AI network to run should be chosen accordingly, so Real ESR GAN. As we had already adjusted the resolution of the image before importing it to upscale, we don't need to touch the resize before upscaling menus, and no need to adjust the resize after upscaling either. As far as the output module goes, I don't see TIFF there, so I'm gonna go with yet another uncompressed format, PNG. Then we can press refresh preview. Give it a few seconds. With a decent video card, it won't take long. Actually, it's surprisingly fast. It's only 8 seconds per image. You can click on the image to reveal before and after, and actually comparison looks striking. Even though the resized output can look, how should I put it, slightly more artificial, it still looks striking to me. Like how it imagines the details. Like, look at this hole. It's crazy. Too bad it doesn't work that good for normal maps and displacement maps. Now we can save the current merged preview, or press upscale and save, and the file with the 4x resolution of the original one will be placed in the same folder. The glorious upscaled image for projection. Double checking it, here's the original 960 pixels wide file, and look at this, 3840 pixels wide, upscaled image. That's insane. Now back into Blender, let's load this image into Image Editor. Here it is. As we have mentioned before, too bad it doesn't work for normal maps and displacement maps because it was trained for different type of data, the neural network I mean. But even for the base color, it's pretty impressive. Look at this. Let's get into the texture painting mode. And in the right panel, in the tool settings, let's find the Apply Camera Image button. Click on it, select the upscaled texture. Bam. Here is a quick before and after. Personally, I like the denoising side effect. I think it draws more attention to the highly defined edges, and that somehow contributes to the perception of upscaling. At least that's my impression of it. We can see this kind of a weird smearing effect at the side of the mesh, and it can be fixed in two ways. The first one involves GIMP again, or any other painting application. Only the opaque pixels get projected, so we can selectively make the pixels around the area that is meant for projection transparent. I'm using the eraser, and the brush is pretty smooth, so the fall-off is not as harsh as it was initially. It won't take long. After we're done, we can save it nearby or on top of the original image to not waste the file space. Export. Replace. Agree with everything. Now back to Blender. This image needs to be refreshed, the image for projection. So in the image editor N, to open the right tool shelf, hit refresh. Enjoy the refreshed image, and now we can use it for reprojection once again. Back into the tool settings, in the texture paint mode, apply the camera image. Now we shouldn't see any weirdness, like any smearing at the sides. That's due to the transparency that doesn't contribute to projection. So it works pretty well. This projection method is fairly experimental, I must say. It may or may not work. The neural network may or may not understand and know how to upscale the image, so to speak. And it takes a fair bit of time to set up all the projections. Like if the first one was the front projection, now we should do the left one, and then the top one, so on and so forth. I'm adjusting the orthographic scale and the camera position for the left projection. And then, as we remember, it needs to be rendered in half of the resolution, in our case, saved as the uncompressed TIFF or something, and super resized. Is there such word? Super scaled? Upresed in Cupscale, which is our neural network-based free resizing application found on GitHub. If we are lucky with our source images, the upscaled result should look somewhat like that, which is totally mind-boggling. I know it's a cliché in that world of neural networks, but it totally reminds me of the enhance command in movies. It's like going Cupscale, enhance, and it churns out the image that is 10x the size of the original one, or 4x, never mind. It's actually pretty crazy. In the tests that I've run, it didn't work as well with the textures, like with the UV maps. And it's justifiable, I guess, because it wasn't trained this way. Okay, so I'm painting the transparency once again in GIMP. Probably this step can be avoided. I will show you the workaround. But anyway, I've just painted the transparency for the projection that we loosely call left. The compression to 0 to make it save faster. And at the speed of light, back to our beloved 3D content creation application. Engage the texture paint mode. Head over to the tool settings. Make sure that the base color is still selected. And then apply the camera image with the new projection selected. I'm gonna undo and redo a few times so we can see before and after. I love after much more than before. Like, look at this, it shouldn't be legal. How about the smearing effect? Yeah, we still see it. Even though we have had some transition between opaque and transparent pixels, it wasn't enough to avoid smearing. What can we do? Luckily, there is a little setting that helps with solving such issues, so if you scroll to the top like this, you'll find the normal fall-off tab. By changing the angle from 80 to, say, 20, you tell Blender to apply the normal fall-off, or to project only to the surfaces that diverge from this vector no more than by 20 degrees or something like that. And that means the surfaces that face the camera. So basically it should be alright now. So that was a pretty quirky, I must admit, but nevertheless super exciting method of upscaling textures in Blender by utilizing projection and free neural networks based application called Cubescale that can be downloaded from GitHub. I like this method in the context of photogrammetry and creating photoscanned 3D assets because it allows to extend the potential threshold of quality, even though this source material wasn't the highest quality possible. Say it was captured on mobile, it suffered from lots of blur or lots of noise, and this method still opens the possibility of enhancing the quality in the end. Here we can see the result of the tutorial presented in Eevee. I think it looks pretty impressive. That was Gleb Alexandrov for CreativeShrimp.com. Thanks for watching our course.